Why? Why can't we do that? Because they're a family, they have a plus sign. We cannot split up a radical over a plus sign. We can't forget that. So we have to leave that radical there for now. And I still need to work around the negatives. So this is going to be 1 over a squared plus 1 over b squared. Still a problem because not only do I have a fraction under a radical, I have a fraction under a radical with another plus sign and another fraction under the radical. So I still can't split these up. I can't split this up into 1 over a squared plus the root of 1 over b squared. I can't do that. Why am I not allowed to do this? For the same reason I couldn't split it up before, because of the plus sign. So we can't do this. So we have to just keep working with the problem until I get it under one radical, under one fraction. So I'm going to make a common denominator. What is the common denominator here? A squared b squared. So I have a squared b squared and b squared up here plus a squared over a squared b squared. Now that I've made that common denominator, now I can turn this into one fraction. So I'm heading in the right direction. So we are b squared plus a squared over a squared b squared. Why is this now the changing point for us? By us creating this under just one fraction, what can I now do, Arav? Good. Now I can split this radical sign into a radical in the numerator and a radical in the denominator. And the radical in the denominator is illegal, right? We're not allowed to have this, but aren't they both perfect squares? So what's the square root of a squared b squared? Just ab. Good? Okay, before we get into other radicals, meaning other radicals with a different index other than 2, I want to show you how we factor with radicals. So when we're factoring, we always look for a GCF first. There's clearly no GCF here. So if we're factoring and there's only 2 terms, our options are either a dots or a cubes, right? Difference of cubes, sum of cubes, or a difference of squares. So this is definitely not a cubes. How do I know this is not a cubes? Because it's x squared, it's not x cubed. So this has to be a dot, but 28 is not a perfect square. That doesn't mean there's not a number times itself that gives us 28. So for a dot, if we have a squared minus b squared, we end up with an a plus b and an a minus b. Do we agree? So here it's going to be an x plus and an x minus. And what am I going to do? I'm going to take that square root of 28 and I'm going to simplify that. What's the square root of 28 in your heads? 2 root 7, perfect. So this becomes a 2 root 7. So we are x plus 2 root 7 and x minus 2 root 7. Okay, next one. Dots are fun. The trinomials are not as fun. So let's say I have x squared minus 2 root 5 x plus 5. Now I know I can factor. There's a trinomial on x squared, then an x, and then a constant. So this is in a good format. There is no GCF. So remember, when we're factoring, we're looking for numbers that multiply to the last number but add to the middle coefficient. So I need factors that multiply to a positive 5 but add to a negative 2 root 5. The only way to add to a radical is if both factors have that radical in it. Does that make sense? The only way I can add two numbers that will add to 2 root 5 is if both numbers have a root 5 in it, unless we can't add them if they don't both have a root 5 in it. So I know right away when I'm coming up with my factors of 5, it has to be a root 5 and a root 5. Now, what's root 5 times root 5? 5. So right now, this alone is 5. So I need 5 times something that will give me 5. And this number that we're plugging in right here, this is going to be the coefficients or the product of the coefficients. Product. So what number times 5 gives us 5? 1. So what does that mean? Each coefficient of my factors, they have to multiply to 1. So what does that mean? Each coefficient has to be 1. But now I have to check this. Not only do I need to multiply to a positive 5, I have to add to a negative 2 root. So 1 root 5 times 1 root 5, that is a positive 5. Do we agree? Root 5 times root 5 is just 5. But is 1 root 5 plus 1 root 5 a negative 2 root 5? No. So what do I know about both the signs? Both signs have to be negative. So let's try this one more time. Negative 1 root 5 times a negative 1 root 5. Is that still a positive 5? Yeah. And now negative 1 root 5 plus a negative 1 root 5. Is that a 2 root 5? Negative 2 root 5? Yeah. So now we're going to have x minus root 5 quantity squared. Let's try another one. So now we need factors that multiply to positive 30, but add to a positive 8 root 2. If I'm going to add to a positive 8 root 2, do we agree that both my factors have to have a root 2 in them? Okay, well then I have root 2 times root 2 is what? 2. So then 2 times some number has to give me 30. 2 times what gives me 30? 15. So this 15 is going to be the product of the coefficients. Now, the two coefficients also have to add to what number? 8. So what will multiply to 15 but also add to 8? 3 and 5. Signs, positive, negatives, what do we think? Positives, because everything is positive. So let's check this. So we have 3 root 2 times 5 root 2. That's going to be 15 times 2. Is that 30? Yep. And then we have 3 root 2 plus 5 root 2. Is that 8 root 2? Yeah. So we got our guesses. So we're x plus 3 root 2 and then an x plus 5 root 2. All right, you guys try one on your own and then we'll move on. I won't ask you to factor anything with a leading coefficient in these radical ones. I'll just be straightforward ones like this. All right, who factored for me? Who has an answer? Kasvi? Perfect. Anybody need to see me do this? Okay, great. Let's move on. So just to recap, because up until this point, everything has had an index of 2. We've been dealing with square roots. Today, we're going to change that. So if I have a radical, remember, this is called the radical. This is called the radicand. And the number by the check mark is called the index. Arav, you're so chatty today. What's going on? Okay, so now the directions are to simplify. And so now I don't have a square root anymore. Now I have a cubed root. So now that there's a cubed root, I'm not looking for pairs. I'm not looking for twins. We're looking for triplets. We want 3 of the same number. So for 8, we could do this in our heads, but I'm taking the long way just to show you. For 8, it's 4 times 2. And then 4 is 2 times 2. So we're looking for our triplet, which is right there. Whatever you circle comes on the outside 1 time. Is there anything left on the inside? No. And that makes sense. Cubed root of 8 is 2 because 2 times 2 times 2 is 8. All right, what about with variables? Let's say I have the cubed root of x to the 12th power. So when it was the square root, what did we do? What was our shortcut? Stephen? Divided by 2. Guess what? Since the index is 3, we're not going to divide by 2. We're going to divide by 3. Exactly. So 12 divided by 3 is 4. X to the 4th. Is there anything left over? No. And this makes perfect sense, right? Because x to the 4th times x to the 4th times x to the 4th is x to the 12th. Okay, now I have the 4th root of 48y to the 6th. So now I'm not looking for a group of 2 or a group of 3. I'm looking for a group of 4 of a kind. We want 4 of the same number. So if we're going to do 48, I'm going to go, I don't know, 16 and 3. Then I'd break down 16 into 4 and 4. And then we could bring down this 4 into 2 and 2, and this 4 into 2 and 2. And there's our grouping of 4. So we know a 2 is coming on the outside. 1, 2 is coming on the outside. And now there's a 3 on the inside. For the y to the 6th power, we're going to say 4 goes into 6 how many times? Just 1 time, with how many left over? So y to the 2nd goes on the inside. Something that you forget on this test, or that I see, not you, I see students forget every time, is in their final answer, they forget to put the index. That's a big problem, because if the index is not there, what is it implying that it is? Square root. This is now the 4th root, right? Very different. So you want to make sure that if the index is not a 2, that you're putting the correct index in. Is it okay that I have a negative under this? Yeah, we can't have a negative under a square root because there's no negative number times itself. that will be a negative number. That leads to an imaginary number. Every negative number times every negative real number times itself becomes a positive number, right? But for a cubed root, when we're looking to multiply 3 times, can 3 negative numbers multiplied together be negative? Absolutely. So what times itself 3 times will give me a negative 125? Good, negative 5. Okay, you guys do these 2 problems now on your own, and then we'll step it up a little bit. Oh, we like it like this? Yeah.
For 7, does it matter if we pull out the negative or like when we end up with our answer? Like, do we have to pull it out with negative? Because
Yeah, we always pull out the negative. We don't leave the negative inside. That's a great question. Yep, for the negative, we always pull out the negative. We do not leave it inside. All right, somebody tell me what'd you get for number 6? No? Just didn't change your mind? All right.
6, I got 2w squared. Squared.
Does anybody need to see me do this?
Oh, yeah,
Oh. -2 for me. Do you have to specify it? The 5th root. I mean, you should. I even forgot to write it. But yeah, as long as you have it on your paper. All right, number 7. What'd we get here? Yep, -2 times the cubed root of 5. Perfect. Anybody need to see me do this one? And the question was, does the negative have to get pulled out or do we leave the negative underneath? The negative always has to get pulled out. We didn't need this one? No? Okay. All right, let's step it up a bit. So before, when we had a square root under the radical, we just multiplied it by itself, right? But the reason we were multiplying a square root by itself is because for a square root, what did we need to come out of the square root? A pair, right? We needed 2 of the same thing. So when you multiplied it by itself, you were immediately creating 2 of the same thing. But now this is not a square root. This is a cubed root. So if I multiplied the cubed root of x squared times itself, don't do this because it's wrong. So if you did this top and bottom, you would get the cubed root of x to the fourth. And the cubed root of x to the fourth, wouldn't that be x times the cubed root of x? So would you still be left with a radical underneath? Yeah, so this doesn't work. You're not going to just multiply it by itself. Again, why did it work when we multiplied a square root by itself? Because we got the pair, and that's what we need for an index of 2. We need 2 of the same kind. But now I need 3 of the same. So right now we're going to think a little bit into this. We have the cubed root of x squared, which is x times x. Do we agree? So now I need a triplet, right? I need 3 of a kind. So in order to make 3 of a kind, I only need how many more x's? 1 more x. So we're going to multiply by the cubed root of just x, top and bottom. So now we get the cubed root of x over x, because that grouping of 3 comes out. This 3 looks like a coefficient. It's not a coefficient. That's the index. What's wrong? Yeah, so because of the index is 3, we need a group of 3, right? We need a triplet. So we already have, because it's x squared, we already have 2 x's, x times x. So when we multiply by that 1 more x, we get x times x times x, which creates the triplet. So 1 comes out, there's nothing left over. Okay, let's try more. The fourth root of 2 over 36 x squared. Okay. Before I separate this, we have 2 over 36. Can I reduce that? So we're going to have the fourth root of 1 over 18 x squared. And now I'm going to split this into the fourth root of 1 over the fourth root of 18 x squared. What's the fourth root of 1? 1. Now we're looking at this fourth root of 18x squared. I want to break this down because I want to make it as small as possible. So when we have 18x squared, we have 9 and 2, and then x times x. Oh, sorry. And then I'm lying. 9 becomes 3 and 3. There we go. So now, in order for me to get things out of the radical, do we all agree I need 4? I need 4 of each thing to come out of the radical. So what does that mean? I need 4 3s, I need 4 2s, and I need 4 x's. So I already have 2 3s. So how many more 3s do I need? 2. So I'm going to multiply by the fourth root of, and I could write it out just like this, 2 more 3s. How many more 2s? 3. So 2 times 2 times 2. And how many more x's? 2. And whatever, oops, I shouldn't have put that equals. And then whatever I multiply the bottom by, I have to multiply the top by. So now in the denominator, I'm left with 1, 3 times 1, 2 times 1, x. Anybody confused with how I transitioned to the 1, 3, 1, 2, 1, x? Sure. So right now we had, I wrote it a little bit sloppy, but when we simplified the 18x squared, or we broke it down into factors, we had 2 3s, 1 2, and 2 x's. And then we multiplied it by 2 more 3s, 3 more 2s, and 2 more x's. So when we multiplied it together, we got 4 3s, 4 2s, and 4 x's. And if we're taking the fourth root of that, then it all works out to come out 1 3 1 2 1 x. Okay. Now in the numerator, we knew the square of the fourth root of 1 was just 1, so it's just going to be our radical. So this is going to be the fourth root of, let's multiply this out. This is 9 times, 2 times 2 is 4 times 8, right? Is 72 x squared. We know we can't simplify that because we already broke it down into factors, right? So this is it. Oh, I forgot to multiply this. This is 6x. So let me rewrite it. All right, let's do another one. You guys try this one. The fourth root of 25a to the third. Okay, who has an answer, Stephen? I got the same. Anybody need to see me do this? Okay. Let's go on to adding and subtracting. Okay, same rule as before. In order to add or subtract, we need not only the same index, but we also need the same what? Radicand, right? We need the same index and we need the same radicand. So 5 times the cubed root of 3, I can't do anything with that, but the cubed root of 24, can we simplify that? Absolutely. So we can break this down into 4 and 6, and then 4 becomes 2 and 2, and 6 becomes 2 and 3. So there's my triplet right there of 2's. So now we have 5 times the cubed root of 3 plus 2 times the cubed root of 3. And now we got to break down that 81. So I have 9 and 9. And then 9 becomes 3 and 3. And the other 9 becomes 3 and 3. So we have a triplet there. So we have 3 times the cubed root of 3. Now that we have the same index and the same radicand for everything, now can I add? Yes. And remember, when you add, you're only add or subtract, you're only adding or subtracting the coefficients. So 5 plus 2 is 7. 7 minus 3 is 4. So we have 4 times the cubed root of 3. All right, multiplying. Now, when we're multiplying, the only rule you need to multiply is that they have the same index. If it's not the same index, you cannot multiply them. But as long as it is the same index, you can always multiply. So we multiply our coefficients, but are there any coefficients here? No. So then we just multiply our radicands. And I'm going to leave this as 8 times 10 times d to the 3 plus 1 is 4 plus 2 is 6. Why do you think I didn't just multiply and write 80?
It's because it's way easier to like split up those.
Yeah, because it's easier just to split up the smaller numbers. So I'm going to say 8 is 4 and 2. 4 is 2 and 2. 10 is 2 and 5. So I'm looking for a group of 4, and between the branches, I get a group of 4. So that group of 4, only 1, 2 is coming out. And remember the rule, oh, sorry, there's a 5 left inside. And the rule for the exponents is I'm going to take my index and divide the exponent by it. So 4 goes into 6 one time. So 1d is left on the outside, and then there's a remainder of 2. So d to the second is in the inside. Okay, so that's multiplying. Let's talk about dividing. Okay, so I can't simplify this fraction at all underneath, right? So I'm going to have to split this up into the cubed root of 2a to the 4th over the cubed root of 27x to the 6th, y to the 15th. Before I try to rationalize, any idea on what we should do before trying to rationalize this? Yeah, see if we can simplify. Why? Because it just makes it smaller for us. So if we can simplify, 27 is 9 and 3, and then 9 is 3 and 3. Isn't that a triplet right there? So I'm going to have 3, and then the cubed root of x to the 6th is x to the 2nd, and the cubed root of y to the 15th is y to the 5th. Is there any radical left? So it was a lot easier for us to simplify before rationalizing because it worked out. Now in my numerator, I can pull an a out, and then I get a times the cubed root of 2a. This is our answer. All right, last thing I need to show you. I know, I'm cutting it close. Sorry, guys. We actually finished the lesson, though, but I'm still not going to assign homework. Or maybe I'll just assign it and then make it due later. I don't know.
Yeah, maybe.
Okay. Because by us finishing this lesson now potentially gives you an extra day of review.
So the homework would be due on.
Yeah. Oh, well, you guys drop tomorrow anyway. But yeah, it'll be due Monday. Can I make this into a dots? No, because a dots isn't going to cancel out the radical. We need to get this. If this is a plus b, we need to multiply it by something to get it to be a cubed plus b cubed. So what is that? Cubes. This is the sum of cubes. So we need to use the sum of cubes. And for the sum of cubes, if I have an a plus b, we're going to multiply it by a squared minus ab plus b squared. Okay, so here the a is 2 cubed root of x, and the b is the cubed root of 5. So we're going to multiply this by a squared. So isn't that 4 cubed root of x squared, a squared? Anybody lost with how I got 4 cubed root of x squared? Okay, minus ab. So this is going to be minus 2 cubed root of 5x plus b squared, which will be the cubed root of 25. And we multiply this times the top and bottom. Yeah. Okay, so our a is 2 cubed root x, right? So a squared is 2 cubed root x times 2 cubed root x, which is going to be 4 cubed root x squared. You know what, guys? We're going to stop here. I'm actually not even going to assign you homework. What I'm going to do is I'm going to finish